Hello and welcome to the video for week 6, and this week we're going to talk a little bit about inheritance and extending classes to make subclasses and how we can reuse functionality of classes. I'm going to take this video's example from this week's lecture notes for lecture 6.1 on page 25, so you can follow along. I'm going to do it roughly similar to that. So the idea is that we want to create a bank account, and the bank account stores things like the customer's name and the balance on their account. And it has pretty simple functionalities, like it's going to have withdraw functionality and deposit, and it's going to keep track of how much money, of course, is in the account. So we can do this. I think I've done this numerous times in class, but let's go ahead and create a bank account class, and we'll just go ahead and start an application, bank account application, or we could just call it bank application. Let's say that it's going to allow us to test some of the functionality of our bank account. So we have a main method here, and the first thing that we're going to want to do is create some bank accounts. Bank account BA is equal to new bank account. And we want to have a constructor that has an input, the customer's name. So we can just go ahead and create that constructor. You should all be quite used to this. So I'm not going to give you too many details. As you can see, I have something that inputs a name. Of course, I'm going to have a private variable for the customer name, like that. And we might want to use good object-oriented programming practices, and we can write get and set methods. You all know how to write get and set methods by now, of course, or you all know how to click on that to generate them anyway. And we can just do this dot set customer name. So that's pretty easy. Of course, we want to keep also the balance of the account. You can use a double, or let's say a double balance like that, and we want to set the balance. Now you'll notice I don't want to create any set methods for those. I might want to create a get method, like get balance. That seems reasonable. Public double get balance, like that, and return this dot balance. And the balance is going to be set to 0 whenever someone opens an account. Now, writing a toString method that allows us to give a string representation of our bank account, and it's going to be something simple like just printing out the name and how much is in the account. So return this dot get customer name plus this dot get balance. It's that simple. And let's have a look and see what we do here. System dot out dot println BA bank account. Give it even a better name than that. Alright, if we run that, see what happens. So as you can see, we have a bank account with $0 in it. We can get even a little bit fancier and have a string formatter for this so that it prints out the balance correctly. So we could have string.format, and we could give it, let's say, percentage 0.2 F, and we give it this dot get balance. And if we run that, we have it nicely printed out as you would expect that a dollar amount would be printed out, with the cents rounded to 2 decimal places. Anyway, that's just an aside. Let's see what we can do with this. Now the first thing, of course, that we're going to want to do is put some money in the account and take some money out of the account, of course. So we're going to write some functionality that allows us to do that. And that's going to be public, let's say deposit, void deposit, whoop, and we're going to give it an amount, double amount, and we're just simply going to check. Now we can check, of course, if the balance, if the amount is greater than 0, of course. But let's suppose it is. So we can say this dot balance plus equals amount. Keep it very simple because we want to do some interesting other things that are interesting with this. So public. Let's say just keeping it with the lecture notes, withdraw, and you want to withdraw an amount, and we have if balance, if this dot balance is greater than or equal to the amount that we're taking out, then we can subtract balance amount. We don't care to check to see if any other sort of conditions exist. We just want to make sure that there's enough money in the account that we can take money out. And we can save that. And then of course we can just go ahead and perform some simple operations like bank account dot deposit $10, or bank account deposit $2, and maybe we want to even withdraw some money, bank account dot withdraw, let's say $3.75. Of course you can't really do that at a cash point, but let's just suppose you're doing this online, and if we run that, we get some output that looks like that. So nothing too fancy, just explains all the different functionality. Now, we've made some assumptions here is that the initial balance of the bank account is going to be 0, and it has some standard deposit and withdraw functionality that we're all used to when we're using our bank account. Imagine that we have other kinds of bank accounts. For instance, you might have a Smart Saver bank account that doesn't let you withdraw funds, but allows you to deposit funds into it. And maybe as a sort of, so these are sort of schemes that will get you to save more. So let's say if you put $100 into your account, that it might get topped up by 5% of whatever you input into the account. So how do we do this? How do we model this sort of functionality? Well, we have a lot of it right here. We know that we're going to have the customer name, the balance. The balance is still going to be set to maybe $50 this time. We could do a lot of things like have the sort of input of a balance here. But ultimately what we'll be doing is duplicating a lot of this functionality like get balance, get customer name, set customer name, and toString, etc., etc. And we don't really want to do that. It's a lot of typing, and it would be a very long video if I had to retype all of this stuff. So what I would propose is that we create a new class, and we can call it Smart Saver class, but then we use the extends keyword, and we say that it extends bank account. So what that actually does is that creates a subclass of bank account. Now the first thing that we need to do when we create a subclass is we have to tell this class how to construct objects of Smart Saver. And what we need is a constructor, and it has to match the super constructor. So we just go ahead and add a Smart Saver constructor. And what this does is it creates a constructor of the same form. So we need a customer name constructor, Smart Saver, input of a customer name. And what happens is it calls the bank account's super constructor. And then we can do other things here. So let's before I continue, let's just run this and see what happens. So what I'm going to do is I've created a bank account up here. What I'm going to do is make a Smart Saver bank account. It is a type of bank account, but it has some special features. So it's a subclass of bank account. So I'm going to call it Smart Account. It's equal to new Smart Account, and it has this constructor which allows you to input a username. I'm going to I'm going to change this to something else, like that. Whoops, sorry. It's a Smart Saver, I mean. So let's see what happens whenever I create a Smart Account and I print it out to the screen. Let's look at this behavior. So I'm going to set a breakpoint. I'm going to debug. And so I'm right here. Have a look at my bank account. It's as you expect. It has a balance and it has a customer name, which is a string. So a double and a string. Now, the Smart Saver account also has those things. It inherits those data attributes from the bank account. So let's have a look. So I've stepped over that and I've created a Smart Account. Now you'll look at it and it has a balance, much like a regular account does, and it has a customer name. So it's inherited those data attributes from the bank account because it is a subclass. Now there's a lot of very interesting behavior that we can perform with this. So not only does it inherit the data attributes, it also inherits the behavior of a bank account. So what do I mean by that? Well, let's have a look. And I'll run it again. So what does it mean to create a Smart Saver account? Well, if we step into the constructor, what we're actually doing is we are initializing a Smart Saver account, but we first have to initialize all of the attributes that it inherits from the bank account. How does it do that? Well, we know how to initialize an account or how to create a bank account. We use a constructor. So how do we access the constructor of bank account from Smart Saver? Well, we use this special keyword super, and in brackets we have the input parameters that match the constructor of the bank account. So if we step into this, then we have access here to the bank account. The customer name is the one that we supplied, which is Robin Banks here. And we run through it. It sets the customer name, sets the balance as well. And then we have all of that implemented. But you'll notice also that we can print this out quite easily because we inherit the behavior of toString. So we have all of that. So now, as I mentioned, the Smart Account has a few different properties. So I was kind of following the lecture slides here. And there's many kinds of bank accounts. The standard bank account is just the one that has the initial balance of 0 and uses standard deposit and withdraw methods. So that's great. We've already done a class for that. What about Smart Saver? Well, it has all of this stuff. It has maybe a name, but it has an initial balance of 50. The withdraw functionality is not available, so that means we can't take any money out of it. And the deposit over 100 is topped up with 5% of the deposit amount. So how do we actually implement that? Well, it's quite easy. So let's start with this. We're going to have to modify a few things, but I think that we can get the initial balance to 50. Now, what I would recommend is that we try here to implement this in the constructor. So that's what we did for bank accounts, is that we set the balance here. So we should be able to move that code and set it to $50 like that. Sets the initial deposit balance of the account. But there's a slight problem here. Because we have set the visibility of balance to private, it basically means that I cannot access this outside of the balance outside of the account. So what we could do is, there's a number of things that we might want to do. We can set it to protected, which, if you remember, is an access modifier that enables subclasses to access this variable. And that might be all right. It might be perfectly reasonable to have, and if you notice this error has gone away, to have any account access the balance. You might not want that. I don't recall exactly how I did it in the lecture notes, but it might be useful to just use the available functionality. So that might be something that you don't want. You really want this to be absolutely private and no access outside of the class, and that is quite a reasonable requirement. It all depends on the requirements of who you're writing the software for. So there's no hard and fast rules. So if this has to be private, then of course we might want to just say, well, you know, the initial deposit or the initial balance is $50. We can use this dot deposit and change the balance that way. To be honest, I kind of like this better because it makes a lot of sense. There's an initial deposit of $50 into your account when you open the account, which is quite reasonable, and it uses it with the deposit. So it does not break the encapsulation of this balance using withdraw and deposit. So that's pretty good, and we can see that if we just print out the smart account. Let's just remove some of this for now because we don't really need it. Let's just put a block comment there. And if we just print out what the smart account looks like, when we create the smart account, then we add immediately $50. And of course, right now, when we add to the account, let's say deposit $100, then it goes ahead and deposits the $100. Let's just put that like that, and you can see the change in the account. But according to these requirements, we have to say that deposits over $100 are topped up with 5% of the deposit amount. So it's not just the functionality of adding the money to the account, we also have to add 5% of the deposit amount. So how can we do that? It's quite easy, actually. What we're going to do is we're going to override some behavior. Public void deposit double amount. Now, this is basically an annotation which allows you to indicate that a method declaration is intended to override a method declaration in its supertype. So what we are doing is we're saying, I don't want necessarily the behavior of the bank account deposit. The Smart Saver is more specific, and I have to add 5% of the deposit amount. So I need to create my own deposit in the Smart Saver. But we still actually kind of like the bank account deposit. And remember, we can't access balance from here. We can't say this. That doesn't work, of course, because it is private. So how do we still use this deposit functionality? Well, we can still access it. Instead of putting this, using this, we can use super.deposit, and we can deposit the amount into the bank account. Now what that does is it actually calls the superclass deposit, which is of course bank account. Now all of this might seem a little bit confusing at first, but I assure you it's not. If you go through several examples, if you come to the lecture, if you do the work in the lab, it'll become secondhand nature to you. But for now, trust me when I say that this uses the bank account super deposit functionality. But of course, we still want to deposit the amount times 5%. Whoops. So we want to actually include the 5% charge. That's the bonus amount added to the account for saving. It's like a promotion. Let's just see what this does, okay? Let's just do an example. So let's say I'm running this here. So the deposit amount should be $105 into my account. So the total amount, since we start with $50 in the account, we deposit $105, so that's $100 plus 100 times 0.05, which is 5 is equal to 105. And in total we should have 155. I hope, if I've done my math right. Let's find out. Ooh, 157. Oh, that's unexpected. Why did that happen? Oh, that's a good question. Does anyone know the answer? I know the answer. It's because we don't check to see if the deposit's over $100. We have to add an if statement. So this is kind of right, but it's not exactly what we want. If amount is greater than or equal to 100, oh, that's ooh, careful. It's deposits over $100. Well, we can make it equal. We can make it over 100. So of course, that's not going to be $155 because we're not inputting anything over 100. Okay, so let's just go back and input 101 and get rid of this calculation. So let's step through this carefully. Right, so here we are, Smart Saver account. So, whoops, let's just do this again. Step into this. So we set up the account by calling the super customer name, and then we call this dot deposit 50. So we go over here up to the overridden method in Smart Saver, and we call super.deposit amount. So what does that do? That calls the deposit method in the bank account. So let's go F6 again to step in. It does it. Oops. Checks to see the amount is greater than 100, which it's not. It's only 50. And we're done. So the balance is 50. And it's printed to the screen. Now let's try this again. Smart account dot deposit $101, F5. So we're going to step into this. So this is calling the bank account deposit with amount of $101. So let's see how this changes up here. F5. Now notice we're in the bank account and we're incrementing the balance by a certain amount, which is 101. So again, this is going to change it to $151. That's great. And now, of course, since the amount is greater than 100, we're going to do it again. We're going to call super.deposit, but we're going to take the amount, multiply it by 5% or 0.05, if you will. The amount is going to be, we're going to actually add $5.05 into the account. I'm printing it to the screen, so the output is $156.05. So let's just review here. I've shown you today how to create a subclass of a bank account. Now you'll notice that the bank account has a lot of behavior here. The behavior, I'm just kind of collapsing it, some of it. So there's behavior to withdraw and deposit money, to get the balance, to get the customer name, to set the customer name, and print it to the screen. To create a string representation of the account. And this is a lot of work. It took me some time to type all that in. So we also wanted to implement something that's very similar to the bank account, and that's the Smart Saver. And it has much of the same functionality. In particular, we looked at the deposit, but it had, for instance, we still have the customer name, we still have the balance, but the deposit functionality was quite different. And the deposit was simply that we needed to deposit the money and add a 5% overall. And we did that by overriding the bank account behavior by introducing our own deposit method. And by doing that, we override the bank account and we're able to then implement the behavior of a Smart Saver. What was the other functionality of the Smart Saver was that the withdraw functionality is not available. That's very easy to implement. We have to override again the bank account's behavior, because if you notice, if we go back to the Smart Saver, I can withdraw, let's say $10. If I run that again, of course you see that I've withdrawn $10 from there. I don't want to allow that. So how do I fix that? Well, I introduce an override method, and it's going to be this method here. So you take the identical method signature, public void withdraw double amount, and you place it. Try that again. You place it here into the Smart Saver. And so how do you override the withdraw? You just simply say no withdraw functionality. You just don't do anything. It's just an empty method. So now if I run this again, I try to withdraw $10. Of course I can't. There's no change to this withdraw functionality. In fact, in a real application, you might have some sort of message indication or some sort of error code that says that you're not allowed to do this. But the easiest way to not allow some functionality is just to create an empty method, and that overrides the behavior. Now there's many more things that you can do with subclasses and the class hierarchy, and we're going to look at that in the lectures and in the labs, and we'll discuss it in great detail. And so I hope to see you there, and enjoy the lab this week. Bye.